Hi everyone. So it's time to move on to kind of step 2 in our process to stoichiometry. So we learned about molar mass in our first video, and so today we're going to talk about using molar mass to convert moles to mass and from mass to moles. So the first thing that I want to talk about is just to remember molar mass. And if you remember that from our last video, molar mass is the mass of 1 mole of an element or compound. And so what that means is that, for instance, if I'm talking about 1 mole of hydrogen, and I asked you to give me the molar mass of hydrogen, hopefully you understand that the molar mass of hydrogen would be 1.008. Okay, so the molar mass of 1 atom of hydrogen, or 1 mole of hydrogen, is 1.008 grams, because mass is in grams. But we can also say, since this is molar mass, and molar mass is the mass of 1 mole, we can say that the mass of 1 mole of hydrogen is 1.00 grams per 1 mole. It still says the same thing, but it kind of helps us work up a conversion factor that we can use to convert between moles and mass. So this is very simple. We know that 1 mole of hydrogen is equal to 1.008 grams, so we can say 1.008 grams per 1 mole. Okay? So, if I want to say the molar mass of sodium, I would say that it is 22.990 grams per mole. Okay? If I wanted to get the molar mass of magnesium chloride, I would say magnesium chloride is 95.211 grams per 1 mole. So if we start thinking of molar mass in terms of this and writing it like that, it will make it much easier to use in a conversion factor. So, as an example of using molar mass to convert moles of a substance to mass of that substance, the first thing that I'm going to show you is just kind of a little outline of what you need to be doing. So if the question gives you this number of moles, whatever that number might be, we'll just start off with that. And so what you're going to do if you're going to do a conversion is we're going to use those brackets like we used in dimensional analysis. So yes, there was a method to my madness for torturing you with dimensional analysis because you used the same technique in this. And so I was thinking ahead. And so now you've seen something like this and know how it works. I know. Crazy, crazy. That teacher would help you like that. Okay, so if it gives you a number of moles, okay, and so if you're wanting to convert to mass, your end goal is going to be the mass of that specific element or compound, whatever it gave you. Sorry for the bad handwriting. Okay, so the way you want to do that is using molar mass. So if I have moles right here, that means that the mole part of my molar mass is going to go on the bottom. And there's always 1 mole of it in molar mass, because molar mass is the mass of 1 mole of a substance. And so that would mean that the mass in grams part of your molar mass goes up top. And so when you're doing this, your moles are going to cancel and you'll wind up with mass of your element or compound. Now, I want you to notice that this that I wrote right here is exactly what I wrote on the previous slide. It's just in words. When I had you write your molar mass, we had the mass in grams that something weighed per 1 mole. So that's all that is right there. It's the same thing. I'll show you. So for instance, here's an example. we'll say that it wants me to find the mass of 3 moles of copper. Okay, that's what it gives me. So I'm going to follow this outline to get me the grams of copper that it asks me for. So it's saying how many grams of copper are in 3 moles of copper. So what I do is I just use my molar mass to convert. Since moles are on the top here, then I know that the 1 mole part goes on the bottom, and it's going to be copper. And the molar mass of copper, if you remember that, or remember how to do that, you look at the periodic table at copper. And copper's molar mass is 63.546 grams per 1 mole. So now I can cancel out moles, and all I have to do is multiply across the top, multiply across the bottom, and divide, and it's going to give me this answer. There are 191 grams of copper in 3 moles of copper. And yes, you don't have to use this dimensional analysis setup to do it. You can do it another way, and that's fine. Just like I usually say, that's fine if you do it your own way. However, if you do use this setup, it will be far more beneficial to you as we move on in our stoichiometry. Okay? I'll just want you to keep that in mind. And if you actually do this math, it comes out to a decimal, but notice I only kept 3 numbers. It's because significant digits, the number that I started off with, has 3 significant digits. So this would be your final answer. Okay? So what we just did was convert moles of an element or compound to grams of an element or compound. You can also do the reverse by just reversing the conversion factor that we just used. So let me show you. Okay, so if instead it asks me to go from mass of the element or compound to the number of moles of that element or compound, I'm just going to do the reverse of what we just did. So I've got my initial setup here. What has been given to me is the mass, so I will be given a mass in grams, and my goal is to get to a number of moles. So the conversion factor that we have to use has to have mass in the bottom, so grams has to go in the bottom. Which means, if it's our molar mass conversion factor, if mass in grams is at the bottom, then that means 1 mole is going to go on the top. And if I do it that way, my mass is going to cancel, leaving me with moles, which is exactly what I wanted. Okay? So I'll give you an example problem. Okay, so in this case, the example problem is saying something like, how many moles of magnesium chloride are in 5.50 grams of magnesium chloride? So always start with what you're given, which was my 5.50 grams of magnesium chloride. So now we just use our molar mass to convert back to moles. And since grams is right here on the top, then that means grams is going to go here on the bottom, specifically grams of magnesium chloride, because that's what we're dealing in. And if you remember from earlier in the slideshow, the molar mass of magnesium chloride is 95.211 grams are in 1 mole of magnesium chloride. So, grams cancel, leaving me with moles, which is what I wanted. And if I multiply across the top, multiply across the bottom, and divide, I'm going to come out with 0.0578 moles of magnesium chloride are in 5.50 grams of magnesium chloride. And again, I kept 3 digits because I started with 3 digits here. So this would be my final answer. Now, if you look at this logically, you can tell if you did it right. So think about it this way. If it takes 95.211 grams of magnesium chloride to make up 1 mole, and I only have 5.50 grams, that means I don't even have close to 1 mole of that compound, which means that my answer should be a small number. And then, ta-da! My answer is a small number. It makes sense. So when you're doing these, just double check yourself. Does this make sense? And if it does, you probably did it right. If it doesn't, you may have flipped your conversion factor. Okay? So let's do some practice problems. Okay, so here are a couple of practice problems with elements. I'm going to pause the video here in just a moment so you can try these on your own, and when you come back, the answers will be up there for you so you can see how you're doing. And here you go. Here are your answers to these two practice problems. Now keep in mind that your decimals may be slightly different from mine because we may be using different periodic tables that have rounded differently. So that can affect your answer slightly. So if you have a slightly different decimal, don't worry about it. Just look and see if it is close. If it is close, I mean within tenths, then you're right. On this one right here, since it only had 3 significant digits here, I had to round accordingly, so that's why that might be a little bit more than a few tenths off. So there's your first round. Now let's move on to a couple more. Okay, here's your last couple practice problems for this video. Now these are going to be different from the other two because this time you're dealing with compounds, and so you'll have to add up the molar mass of the compound because you're not just dealing with an element. So again, I'm going to pause the video in just a moment so that you can try these on your own. All right, and here are your answers. Once again, remember that our rounding could be different because of the periodic tables that we're using. So if your answer's very close to this, then you are correct. Look at the work. If you did the same work that I did, then you're good to go. I'll be sending out some more practice on this on Wednesday, and then we will be moving on, I'll be sending out more practice on this on Friday, and then we will be moving on Monday to continue with our stoichiometry unit. I'll talk to you all soon.